Hello again. So this is a project about a room brightness maintainer I've been wanting to build. Basically, I hate waking up in the dark. There's no windows in my room. So I put a light in the room that emulates the light level outside. So for circadian rhythm, because it's very important to have like a bright light in your eyes when you wake up. Not everyone's like that, but I like that. So I made that in this video. And the great thing about this project is it has a lot of space to scale. Like, now that the coating, the sensors are built, I can just put on more light if I need to, because the sun's really bright, so it might not be bright enough. And you need a lot of light for your circadian rhythm, so. I should probably record this. This is a light dimmer I'm working on. I got this component off Amazon. It's a triac with a zero crossing output, and I went through all the libraries I could find. I mean, it's just on Arduino. I guess you could find more, but the last one worked. It's by this fellow from 2017, and you just write the brightness right there. Pretty simple. So, show you the sunset simulator. 9000 for the triangle wave. Might have put an extra 0 on the end of the I++ function. There you go. It's a little faster, but it's pretty cool. I'm very excited. And get the full brightness and back to 0. Pretty cool. Pulled this little 120 volt to 5 volt adapter. It's very cute. It was a little transformer out of this doofongle. You can see that's been broken for many years, but 5 volt. Stuffed it up in there. So, use. I should probably explain like what I'm doing. This is really a kind of a light simulator. So my room doesn't have a window outside like this, but I'd like one. So if I put that light box in the corner or above my bed or somewhere, and I put 2 photoresistors, light sensing voltage dividers, imagine a 10K resistor in series here, tap the middle, read the voltage, you can tell the difference. Instead of me, trying to fang-dangle my way into converting the light out here to a resistance to the exact same light in the room, I just can use 2 sensors, 2 photoresistors, and then I can compare the light level at the same distance from the window or the bulb in the room, and roughly get the same intensity of light or same level of light, and then I can control the bulb with the triac, which wasn't working before. So yeah, with the sun, we have my room, and then we can compare R1 and R2, and we can increase or decrease the triac bulb, the LED bank, to mimic the level of light outside in the living room, basically. So let's see if it works. I'm not at my shed, so I basically have no materials to work with, so this should be really sketchy. Here are my two photoresistors. I'm measuring over the 10K in series with them, 10K resistor. So an increase in light will give me an increase in voltage. So some capacitors out there, because these are going to be on the end of the long wires, and I want to get rid of some noise. Here we have our two light sensors, 3 wires each. This is really cheap wire I bought at Home Depot. One's short, one's long, one's for the room, one's for the living room. The one for the living room has the capacitor at the end. Well, this one does too, but it's smaller capacitor. So here's the raw analog output for the room sensor. You can see the voltage and light level are correlated the same. So if I cover this, it goes down because there's very little light. If I show it, there's a lot of light. And if I put this on the bulb right here, see, dim, brighter, 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 and it turns off. Wow, it's pretty bright. 5000 and off. So the other one's down there that goes to the window. This one's for feedback in the room. This is the fun part. Now that they're tied, so I can point them at the light up there. Brighter, brighter. Point it at yourself. Runaway effect. Do it. Yeah, that runaway effect. So I'm taking the brightness of the room right now, and I'm basically setting the brightness to the brightness of those lights on a 1-to-1 and 1-to-1, as well as I can, to truncate the total sensor range of the sensor into the lights. That's fun. And then off. Pretty cool. So now I can use this sensor and the other sensor. I can use this one as feedback, and then I can set the target with the long sensor that will be outside and near the window. So analog, read the voltage in. It's going to be from almost to 0 up to 1024, because it's a 10-bit analog digital converter. And then we divide that by 2048, which takes our number from 0 to 1000 and turns it into a number from 0 to 0.5. And then we shift the whole thing up to 0.2 because the lights don't turn on from 0 to 0.2. They turn on from 0.2 to 0.7. That's basically their active region. Anything above or below that, they either don't work properly or aren't on at all. So we have some safety brackets down here to basically keep that always within the band. And yeah. So there's the feedback sensor telling me how bright it is. And essentially what's going on is the brightness this sensor sees, at least the voltage that's emulated out of this one, wants to match the voltage on there. And the Arduino will power the lights up or down to match the voltages on these two sensors. So we have a match. I'll move it towards the sensor. As I do, these get brighter. So the brightness that that sensor sees is equivalent to the brightness this sensor sees. Oh shit. Ish. I mean, probably not perfect. There's tolerances in the photoresistors. There's tolerances in the voltages. There's, but for the most part, it's pretty cool. So here's I reaching stability around 25 or 26. So the whole light is the magnitude on the sensor right here. This is the outside sensor. And it's like 0.37. And then the room light follows that by changing the light intensity, which changes the voltage on there. So you can see if I block the input sensor, it follows. And there's some lag. You can see the input sensor on the left value. Watch, I'll uncover it with my thumb. It will jump up, and the one on the right, and then it sees there's a difference, so it increases the brightness of the lights, and then that raises the voltage on there, which increases the right column. So, see? Do it again. Look at the light. Covered, uncovered. Covered the sensor, uncovered. So, and I can point it at like the light up here. It gets brighter, point it away, gets dimmer. Point it at it, gets brighter. So hopefully this is works for kind of making me forget that I don't have a window in my room, because I like a window in my room. Probably not the safest thing I've ever made, but we'll close this panel up. This is the switch back here, and we have 5 volts in, and then the triac data connection, the Arduino. You know, I've never used the sticky pad on the back of one of these. Finally used it. This is the triac 0 crossing, and then PMW signal, and then we have the 2 light sensors going to analog 0 and analog 1, and their subsequent power. Big capacitor on the board, so light sensors come out right here. Everything's glued together. I really don't have a soldering iron or a shrink wrap or anything nice like that, but it works. Time for the moment of truth. I ran a sensor out here. Ooh, that. Let's see if I turn the natural lights on. Dials them way down. These are very harsh LEDs. I like these warm ones. So we have the feedback sensor up here. This isn't permanent. Really, I want to put this up here, but I don't have big magnets yet to tack it up there. So feedback sensor there, and the signal sensor looks at the windows out here. The photoresistor pointing towards the windows. It's actually really cool. So I'll turn these lights off. So I guess you'd call this like a room brightness maintainer? Something like that. It's to maintain the brightness. Doot. Doot. Oh, that's nice. Even when the hallway lights are off, it's still visible. So I'd probably change that in the code. Cause a threshold to completely turn the signal off. This is just very basic, but pretty cool. See if you guys can. Pretty cool. Pretty cool. Yeah, you didn't know I hate waking up without a sunrise. So even if it's cloudy out, I'll take that. Waking up in pitch black. It's the only window I got up there. Look. Only window I have. What is that? It's not a